Hello, class, and today we will be doing the 1.2a lesson, solving multiple step linear equations with variables on both sides. We finally made it to section 1.2, and hopefully you learned a lot from section 1.1. Uh, this section is going to be kind of like an extension of what we've already practiced a lot of. We'll still be solving for x, but now things are going to be slightly more complicated. Let's go ahead and start with a word problem. Number one says, two students, Theo and Lance, each have some chocolates. They know that they have the same number of chocolates. That's interesting. Okay. Theo has 10 full bags of chocolates and 47 loose chocolates. Okay. Lance has 1.5 as many full bags of chocolates as Theo, but 35 fewer loose chocolates than Theo. Interesting. Define a variable and write two expressions, one that represents Theo's situation and one that represents Lance's situation. Okay, so this is kind of interesting. Let's first underline a few things or maybe even highlight some things. It says they have the same total number of chocolates, right? So you can kind of see that we know that we can set them equal to each other. Theo has 10 full bags. How many chocolates are in a bag? We don't really know. But we do know that Theo has 10 full bags and then 47 kind of loose chocolates just on the side. Lance has 1.5 as many full bags of chocolates as Theo, right? 1.5. But 35 fewer loose chocolates than Theo. Okay, so I think it's now time for us to just, write some expressions for each person. Let's first define x. So what do you think should be defined as x? Well, the thing that we do not know right now is how many chocolates are in a full bag. So let's have x represent amount of chocolates in a full bag, right? And once we know that, we can slowly start defining Theo and Lance as an expression. Theo has 10 full bags, so we have X is a full bag. He has 10 of those, and he has 47 loose chocolates. So I'm going to go ahead and write Theo as 10x plus 47. Okay, so now we have to define Lance. Lance has 1.5 as many full bags of chocolates as Theo. So it's kind of like Lance has 1.5 times the amount of full bags of chocolates. And if Theo has 10 full bags, what's 1.5 times 10? Right? 15x is what you should have realized. 35 fewer loose chocolates. So it's kind of like 35 fewer than 47 loose chocolates. Well, then again, what's 47 minus 35? I hope you're able to calculate that to be 12, right? That's 35 fewer. Use the expressions to find how many chocolates are in a full bag. How are we supposed to calculate how many chocolates are in a full bag? What is the one piece of information that we still haven't used yet? Oh, they have the same number of chocolates. So now I know that I can set them equal to each other, right? And this is what we're doing all lesson. We're solving for the variable x, even though there are variables on both sides. I'm going to go ahead and set Theo on the left side. 10x plus 47 is equal to 15x plus 12. Okay, so let's go ahead and just talk. How do you solve this, right? there are so many little subtle rules that I have always told my students to follow. One of the first rules that I like to follow is always try to keep your variable positive, right? You always want to try to subtract the variable from the side that would allow you to keep and maintain a positive value for your x, right? Technically, I could subtract 15x from both sides. Technically, I could also subtract 10x from both sides. But I'm actually going to choose to subtract 10x from both sides because I want to always try to keep my variable positive. Okay. And really, in order to solve for the variable, you want all of the variables to be on one side, and you want all of the constants to be on the other side, right? You basically have to decide how do you want to shift your equation, right? So I'm going to get 47 equals 5x plus 12. Now, doesn't this look like a two-step equation that we're pretty comfortable with at this point? It's a little bit flipped where the expression should technically be on the left and this should be on the right. We're used to seeing that. But if you want to flip at this stage, you can, right? I'm going to show you that, yeah, of course you can do that. You could flip it to 5x plus 12 is equal to 47 if you want, right? Then this is kind of like muscle memory, right? We know that 12 is the constant that we have to move away. We have to do this in order to isolate our variable. And we always get rid of the constant as our first step. You then get 5x is equal to 35. And it's rather obvious what x has to be, right? X is going to equal 7. Box your answer. Okay? So I hope you saw that, of course, you don't have to subtract 10x from both sides. You could have subtracted 15x from both sides and you would have been fine. I just like to keep the variable positive because it prevents me from having to multiply or divide by a negative later on. Okay, so now that I know that x is 7 and you basically know that a full bag has 7 chocolates, it says how many chocolates do Theo and Lance have? Remember that they have the same amount. I'm going to plug it in, right? And this is what we call verifying eventually on the second half of this page. Whenever you find the answer for x, you want to check and make sure it satisfies the context or it satisfies the equation, right? This is a form of verification. So Theo is going to have 10 times 7 plus 47, which equals, I believe that's 117. Lance, let's just double check and make sure they both expressions are correct and they both have the same amount when x is 7. So 15 times 7 plus 12. 15 times 7, that's 105, right? 70 plus 35. 15 times 7, 105. 105 plus 12 is 117. So they are both at 117. Okay. So you'd say Theo and Lance both have 117 chocolates. That's a lot of chocolate. Okay, so the principles of solving for a variable when variables are on both sides are pretty simple, right? Push all of the variables to one side, push all of the constants to the other side. That's what we do to solve for x or any variable. Okay, so let's go ahead and now go to number 2. You can see how the expression on the left can be simplified, right? We have an 8n, we have an n, we have a 10. The expression on the right is already simplified. So I'm going to go ahead and simplify the left side a little bit more. I get 9n plus 10 is equal to 50 minus 11n. Okay? And now, again, there are many routes you can go, but my number one tip my strategy has always been to try to avoid a negative variable. So even though I could subtract -9 from both sides, I'm not going to choose to do that. I'd rather add 11n to both sides because it maintains a positive coefficient for my variable. Okay. Now, also, if you feel comfortable enough, you can do 2 steps at once. You kind of know that I want to move the 10 to the other side and get rid of this 10. And you also know that I want to move the -11n to the left side. Okay, as you get more comfortable, this will become easier for you. It will be faster. You obviously want to be careful. Maybe you shouldn't do 2 steps right away, but as you get more comfortable, you realize the left side is 20n, and then the right side is 50 minus 10, which is 40. Okay, and you divide both sides by 20, and you get n is equal to 2. Now let's make sure our answer is correct. Okay. Now this is a little bit of extra work, but it's going to be worth it because you want to make sure that your answer is correct, right? So I'm going to plug in 2 to every variable I see in the original, and I want to make sure that it's a true statement. It's correctly equal to the left side is equal to the right side, basically. Okay, let's check. So 8 times 2 is 16. 10 and 2 is 12. That's pretty much 28. And is that the same thing as 50 minus 11 times 2, which is 22? And it is indeed 28. So you know you're right. Okay. Look at this work. Look at how nice and neat it is. This is the kind of work you want to show on your homework. This is the kind of work that you want to do to be, fully understand all of the steps. Okay, I'm gonna keep moving. Let's go to number 4. Right. So number 4, it says, show algebraically 2 different methods to solve the equation. 2 times a group of 5x minus 6 equals 4 times a group of 2 minus 7x. Your first step must be different in each method. Okay. So I think the first strategy that I'm going to use is the one that I think most of us are comfortable with, which is distributing the values outside of the group, right? So method 1, I'm going to call distribute the values outside the group. Okay, this is kind of like our bread and butter. If you feel like you don't know what your first step is, maybe distributing should always be your first step, right? So I'm going to get 2 times 5x minus 6 equals 4 times 2 minus 7x. Okay, so now let's distribute, and then we'll get a more simpler equation. Be careful, always distribute correctly. 10x minus 12 equals 8 minus 28x. Okay, sometimes when you're in the middle of a problem too, it could help to visually just double check, right? Okay, so far so good. Okay, so now you want to follow my strategy of always keeping your variable positive, right? Try to keep your variable on the left side, but also try to make sure that your variable stays positive. So I'm going to add 28x to the left side, right? This allows me to eliminate this variable on the right, have a constant on the right side, and then it gives me this larger chunk of the variable on the left side. And that's okay, and that's what we want to see. Running a little bit out of space, but I'm going to write it as 38x minus 12 is equal to 8. And you could already tell, class, that this number is not going to be very clean. So I'm getting 38x is equal to 20, and then you divide both sides by 38. divide both sides by 38, and you get x is equal to, now you always want to simplify this, right? You have to simplify whenever possible. They're both even numbers, so I'm going to simplify this as 10 over 19. Nice. Okay, so the next strategy that I'm going to use, though, is kind of like, I think it potentially is easier, but they're both decent. I'm going to go ahead and divide both sides by 2 first. I'm going to divide away this 2. Remember that you could always divide away that number in front of the group if you want, right? Divide both sides by 2 first. And if you do that, it kind of makes the left side easier. Now, the right side will still have a value at the end, but I'm going to show that right now. So 2 times 5x minus 6 is equal to 4 times 2 minus 7x. Okay, so if I divide the entire equation by 2, I will effectively get rid of this 2, which is nice. You'll have the group. Remember, you never divide within the group. The group is kind of closed, and you just have to divide what's outside of the group. So 4 divided by 2 and 2 divided by 2. 2 divided by 2 is 1, so then I get a 5x minus 6 just kind of by itself. And then a 4 divided by 2 is still a 2, and then you have what's left in the group still. Okay, so there's really no way to get rid of that number entirely, so we then have to then distribute again. Now, you might say, well, isn't this kind of like method 1? Kind of, but it's just another route as your first step. Okay, so now I'm going to add 14x because I want to keep my variable positive. I'm also going to add 6, kind of like a 2-step in 1. And I'm going to get 19x is equal to 10. Because 4 plus 6 is 10, and then 5 plus 4x is, or 14x is 19x. You then divide by 19, and you realize that I arrived at the same answer. Okay, these questions are taking a little bit more time. That's totally normal, right? We are at the stage of solving for a variable with variables on both sides, and obviously that is going to take a little bit more time than just having a variable on one side. All right, let's take a quick break, and I'll see you at the next part 2 video.